who is a very renowned researcher and a professional IT consultant that whose research and professional life has spanned over 33 years. And Dr. Umachandran is someone that has been in the industry for many, many years with a vast knowledge in Africa here, in Asia, Europe, and beyond. So his knowledge is something that can really take us to the next level of understanding what the current IT and technological innovations we gain students, we gain professionals today and in the future. So he's currently a managing general manager at Netcast, India, one of the largest company in India that involves in iron foundries and the manufacturing machineries for big and multinational companies. He's a general manager, and his research area academically is in the field of deep learning, machine learning, AI, digital transformation, and many, many, many more. And he has published quite vastly and cited as well. When you check his profile on Google Scholars and ResearchGate, that will give you enough idea of whom we are talking about. And we're looking at his vast knowledge on Industry 4.0. Will give you an idea of what he's going to be talking about this morning on deep learning and machine learning, where industry are using this technique in positioning themselves as one of the global players in different fields. So please, let's give him the audience and let him talk to us on those ideas that that can really change our career. Doctor, please, can you?
Yeah, thank you. Thank you. I hope you're listening. I mean, you're able to listen to me, Dr. Joshua?
Yes.
Can you hear me?
Yes.
Oh, very
I
nice.
can hear you.
Okay. Good morning, friends. Friends, I mean, everyone who's present and who's about to join us in the future, right? I'm going to talk to you something which is very valuable to you, because as students, we have three options in front of us as we pass out from a university. One, to go for higher studies. Two, yeah, three-pronged. One is for higher studies or for employment, or to start on our own. So for all these three, I have an answer in this 1 hour session, which I'm going to handle with you. Okay, me, Dr. Krishnan Umachandran, I have a wonderful experience in front of me, which I'm willing to share. That is one of my positive aspects, which I am projecting to you so that you can be benefited. Why I'm telling this that you can be benefited is, the world is shrinking because of technology. There is no division between people where you are born or where you are. And similarly, the opportunity to grow is also wide. Wherever you study or whatever you do is going to impact everyone in the world because of technology. So this technology is going to go for taking more people into its fold of employment. See, UNIDO, United Nations Industrial Development Organization, in its Agenda 2030 has projected, that is from 10 years from now, that is, we are now in 2020, in 2030. In 2030, they have their goal, 9th goal, specified as to build a resilient infrastructure with inclusiveness and sustainable industrialization, fostering innovation. These are the 4 I's they are taking for the people who are graduating to be employed and grow in industries. One is on the infrastructure. Okay, where we are, what we are doing, where we live, where we move, everything, all the infrastructure, buildings, conduits, connectivities, and everything. Leave that. The second is inclusiveness. all people without any bias, gender-based or religious clashes, or removing all kind of barriers between human beings. Everyone is going to be inclusive, and everyone is going to have equal opportunity, provided you have the potential to win the job. Number three is industrialization. Industrialization will be sustainable. It means it will run for some period of time without much of a change that is going to impact the people who are being employed. Then the fourth part is innovation, the creativity and innovation part that is going to go along with it. Be whatever it is. They have identified 5 clusters which is going to affect the whole world. One is bioscience, medicine, and healthcare. That is the first prime one, which already the European nations have started investing their time, money, energy, and the development of people into it. The second is energy, where Western countries like America and the Eastern China have already plunged into making more of investment towards the energy segment and that sector. The third one is defense. Defense, in particular, they are going for aerospace. Aerospace, aviation, that is going to be the tool of movement, which is going to connect people. And then the fourth one is going to be the transportation, because people will be frequently moving, and what are the novel things which are going to come in transportation is the fourth one. And fifth is the digital innovation, which is going to employ more people. So these 5 in a cluster of industries are the one which are going to give future employment. I am now going to talk on the digital environment, which is evolving for the future. In the digital environment, we already have seen for the last 1 decade or plus, lot of developments has happened in ICT, information communication technology, where mobile telecoms have been spread all across the world. Now in Africa, you see every nook and corner can be connected by mobile phones. So communication is being established, internet is available, and people are in a position to be connected. So the next level, the future which is coming, is use of this internet, which is called the Industry 4.0. This Industry 4.0 is the future employable conduit among people for getting employed and prospering. I'm going to use this, the opportunity to go into this and tell you like what are the opportunities you have, or you can get specialized so that you can take your career further on. See, Industry 4.0 is a technological umbrella. Like, you have a lot of technologies, simulation technology, you have systems integrations, you have cloud computing, you have cybersecurity, additive manufacturing, augmented reality, IoTs, big data, and then robotics. These are the 9 technologies that are involved into Industry 4.0. This technology depends on the functionalities. Straight away, this technology cannot come. It has to depend on certain basics. Like, for example, you take a car. The car is a big vehicle, but within that there is certain thing called engine. That is a prime mover, and then you have the controlling aspects like braking system. Then you have the fuel system, like that. After the technology, below the technology on which lingers is the functionalities. For this Industry 4.0, the functionalities are interoperability, transparency, real-time processing of data, and then digital automation. These are the 4 aspects on which the Industry 4.0 sits on. So the basement for Industry 4.0 is your functionality. But this functionality has to sit on something else, that is called the features. The features for these functionalities are CPS, cyber physical systems, artificial intelligence, machine learning, your predictive data modeling, and digital twin. These are the basements for the foundation called functionality, upon which sits the technology or the Industry 4.0 umbrella. So now below these features comes the components, like your hardware, software, your mechanical components, electrical components, electronic components, semiconductors, everything. So I'm not going to touch on the component side. I am going to get onto the features. That is, what is that which we study now can help us to go and get a better future or employability, which makes us flourishable for our career. Okay, this is on this. There are many things that can be taken, but I'm going to take only ML. I said about CPS, cyber physical systems, artificial intelligence, ML, that is machine learning, predictive data modeling, and then finally digital twin. In that string, ML is the one which I'm going to talk about. But ML, if you see, machine learning, machine is the one we have a lot of machines. Machines per se, if I say machine, it is physical machine. It can be any gadgets, it can be any devices, it can be any equipments, which all function on internet. It means every machine or gadget or device or equipment is going to be connected with internet, and then it is going to be controlled in the future. So for which we require machine learning. This machine learning has gone in for a development called deep learning. So the focus of my talk is going to be deep learning and machine learning for today. Okay, this is the broad aspect on which I'm going to talk to you. This I wanted to share with you before I go on showing my presentation and then picking it up. Dr. Joshua, I'm going to share my presentation. You have to allow me now.
Okay, no problem.
Right. So this is the topic, deep learning, machine learning, skills, employment opportunities. Okay. See, important thing with deep learning or machine learning is we are going to consider the machine like a human being. Okay, I'll show you the model on which the bigger picture is going to be created for this talk today. You have a look at this picture which I'm showing you. Are you able to see this DLML skills with a kind of a butterfly flapping model?
Yes.
Okay. On the, I think, Dr. Joshua, you have to prompt me because then it will be convenient for me to understand whether you can hear or others can also hear on your behalf. Okay.
Yeah.
The one
Yes,
is you can see. Yeah.
Yes, we can see it. Just the audio is a little bit cracking. But if not, the picture quality is fine.
Oh, God.
Yeah.
Okay. Then I'll see that if I can increase my volumes also.
Okay.
Okay. How about now?
Yes, is better.
Very good.
Okay, thank you.
I've kept it in a full volume. Right? So
Okay.
I think it's like you have two wings of a butterfly like model. Okay, the first right side is called CS, and then you have a X-shaped pattern. Okay, that is the human side of the involvement that is required to the machine learning. And on the right side, you see ML, and then you see a kind of a oval pattern, okay, which is on the machine side. So we are going to link the human kind of thinking and their intelligence into the machine. How are we going to do it? Okay, see, human beings have a SR relationship. SR relationship means stimuli response, and they are also intelligent. And the third part is they have a kind of a meticulous operational lead, and they are also smart. So how to bring all these things into the machine is what we are going to see. And as the machine becomes intelligent, how we have to use it for a machine learning and then deep learning is the concept on which I'm going to talk to you. So if you go further, this human-oriented intelligence, if you see, it is dependent on stimuli response. Stimuli response means if a person is affected by a stimuli, see, for example, you hit somebody or you shout at somebody, that person, which is called organism O, he or she is going to respond. If they respond positively, it is okay. If they respond negatively, it is because of various reasons. Okay, this is called SOR model: stimuli, organism, and a response. You consider now, in place of O, you are going to keep the machine. You are going to give a stimuli to it and it responds. If that kind of a response comes, it is only a machine-oriented response. Whereas another model which is there in SR model, that is called SOBC, where you give a stimuli and then the organism behaves in such a way that when it gives you a kind of a result, it checks for a feedback, and then based on the consequence, it behaves continuously. This is called SOBC: stimuli, organism, behavior, and consequence. Similarly, on this O of SOBC, if you keep a machine and you give a stimuli, the machine will behave, and then based on the consequences of you accepting it or not, it will change its future movements or future way of working. This is what is called SOBC. This SOBC is a prime base of a model that is going to be implemented in machines, which is called deep learning. Okay, now we are going to say that we want to make the machine to be intelligent. But what is intelligence? Intelligence is nothing but you collect data, you process data, you quickly respond for some decision. So it is a function for quick response of a collection, processing, and decision making. That has to be done by a machine. So this intelligence aspect is going to be fed into the machine. But if you do it in the machine, what happens is there can be two ways. One, a meticulous way, and a smart way of functioning of the machine. Meticulous way is nothing but you get into the detailed action and be careful, you be attentive of everything, and then you start working. But then it will take time. For example, your computers are meticulous machines. But when can a computer become smart? Only if it can apply learning. So it had done at a certain situation in a certain way, and that learning has to be transferred for the future programs. That way, this human orientation is going to be fed into the machine so that the machines can become smart. Okay, for this aspect, we require people, with a kind of a cognitive science, inputs. Cognitive science, if you say, cognitive science is nothing but interdisciplinary science. It has BCM, that is biology, computer science, and neuroscience as its multidisciplinary inputs. This is for learning, inference, concepts, and activities of mind. And that mind has to be applied into AI. See, mind means what? Mind is nothing but thought and feelings. You can create a machine which can think like you, but it should also have feelings like you. Then only the machine can be intelligent enough and called a machine with deep learning. If it is without feelings, then it is only a machine learning. So these aspects are going to be built into the machine. As we go further, you can really understand how I'm going to put it into the requirements. See, the need for machine intelligence. If you want to have any machine, and that machine has to give you a kind of a comfort and coziness for esteemed life and living, then that machine needs to be intelligent. Otherwise, it will be just a switch on and switch off kind of a machine. A switch on and a switch off kind of a machine are no longer going to be in existence in future. Every machine is going to ask you for feedback, and that feedback is going to be corrected, and it will be in the long-term memory of the machine. Accordingly, it will start reacting to your emotions in the future. This is what is called the machine intelligence that will be fed as an expected part into the machine. So if you want to have a machine-oriented intelligence, it should deliver an intended process intelligently. It will have sensors, it will have transducers, and it will have a computing device. And moreover, it will communicate between machines through a IoT. The IoT is the one which will connect all the physical machines. This is the basic requirement of the infrastructure on which the digital media is going to be going up for the further. Then, when I said data has to be processed, collected, and computed quickly, this is called the big data. Big data has 5 V's. It is a voluminous chunk of data. It is speedily collected. It has a good velocity. It is variety. That is, from various sources, from various people, from various locations, it is going to be collected. And then veracity, like situational accuracy is going to be built into it, and variability, at what frequency it has to be collected and kept, stored, computed, or done with all this. So all these 5Bs are the ones which is affecting big data. Big data has a kind of a usage, optional usage form. That is called, if you get a data, you can use it, or you can misuse it, or you can manipulate it, or you can hush it. This is what human beings do. So if you want to have a machine which is going to be intelligent, then means the machine should also know where you will use it, where you will misuse it, where you will manipulate it, where you will hush it. So the machine is not going to be a dumb one sitting waiting for your orders. No, it is going to become intelligent, so it is going to question you. So when you are going to question, then there are stages on which this big data is going to be progressed. The 4 places at which this big data is going to be processed is, one is called the warehouse. First, you collect the data and stack it. That's called warehouse of the data. Then you have to compute it. Data computing, either in a tabular form or in a whatever format you want to collect the data, you keep it. Then you have to engineer it. It means you have to position the data in a way that you can make a decision out of it, or you can infer from it. This is called the patterning, logical reasoning, and many other ways on which you have to go on with the data. And finally, the mining part, which is the enriched data, which you are going to take it and apply for your application or your reasoning. This is where the warehouse, computing, engineering, and data mining are the 4 stages on which the big data has progressed. As we do it, what we want to do is, finally, you have to aggregate the data, apply analytics, enrich the data after big data. Okay, we have got the data, and we are going to use it for enriched data, and then we are going to take informed decisions. Okay, because computing devices work on only data, and those data can be used, misused, manipulated, or hushed, which I have already told you. And they are in a process in various stages. One is in the data warehouse, data computing, data engineering, and then you have a data mining part. And finally, you use logics of patterns or opportunities or hack it for a right data. This is how the big data is being used. Okay. As we go further, the data by per se, it cannot give us any kind of kind of a pathway. We have to identify a kind of equation on which to use this, which is called as algorithm. An algorithm is like an equation which we create for providing us a solution. This algorithm can be of many things, like it can be of algebra, it can be of spatial measurements or mensuration. Like, you up from a sky, you see a field, you go with the length measures, breadth, any measures of it, and then you do the calculations. Or metrology, you have certain devices which give you an input, and that a device input is being used for any calculation. That's called metrology and mensuration. And finally, bioinformatics. Whatever you see, whatever you hear, talk, everything, all your human inputs. Those things can be put into, and then you create a kind of an equation. That equation is being used for getting out an intelligent decision. But to become intelligent decision making, the thing which we are going to create in a machine is called artificial intelligence, which is AI. AI is going to have 4 big components. One, the big data, which we have already seen. Then the algorithm, which we are going to program and keep it. Then we have to feed it with past experience. There are certain things in the past we would have gone through, that positives and negatives have to be fed into it. And finally, the outcome has to be adjusted or scaled up. Adjustment is for making it less, scaling up is going for high. So these are the 4 factors on which any artificial intelligence will work. But this artificial intelligence is going to be in the neural network of the machine, artificial neural network, and that neural network is going to be checked for whether it can be economical, it can be practical, whether it is an expensive and time-consuming activity, or it is instinctive, or it is transactional, or should I dig it from an archive, or I have to get it from an experimentation, or I have to do it from an explorative action. All these things have to be summed up, based on which only an artificial intelligence can be prepared, and that will be tuned to the algorithm. So to tune an algorithm, you need to have all the coordinates of these controls called knowledge resources on which you have to depend and then pick it up. Then the next part of this machine is where we are going to come the machine learning. So to come to what is called machine learning, you should know what is an AI, artificial intelligence. You should know algorithm. You should know big data. You should know the connectivities and components of the machine, and then only you have to come to machine learning. So machine learning is now an artificial neural network. It has an application of AI. It is the system which has the ability to automatically learn. It is not like an artificial intelligence. You have a program. Here, for example, if an ant is coming and biting you, okay, if an ant is coming and biting you, your hand will not keep quiet. Your hand will automatically sweep and it will shove it off or it will hit it. If a mosquito is going to come and bite you, for that stimuli, your hand will be much more quick in its reflex and it will hit you. If, for example, a small housefly is going to come and sit on you or on your shoulder, will your hand give the same amount of effort like what an ant required or a mosquito required? No, it will not. Because for this, I can just push it off, sway it off. Now, this kind of a movement, all these three activities had the same movement, but intensity or the effort and the timing at which the action is required vary. Similarly, the machine will learn for the same activity, but for a different kind of an expected outcome, how it should perform. This is called machine learning. So it will improve from the experience. It will learn from the performance tasks, and without explicit programming, the machine will learn. How? This is called the linear perceptron. In machine learning, there are 4 aspects. One is called the interactive. Interactiveness is nothing but every machine can have a graph or a map or a chart that can give you a kind of data. Then that has to be featured. Featured in the sense it can be modeled, or it has to be timed. Each aspect has to be timed, or it has to be given to different people or different resources. It's called deployment. So when you have these features linked, then you go on for the data mining. Data mining is where here you also have an algorithm which will be connected with the hyperparameters that will have classification regression. It will go with your cluster analysis, time series, anomaly detection, all those aspects of numerical analysis, and then it will give you an output on a chat, which can be a voice-based or a text-based, based on which you take a decision, and then the machine again will learn from whatever decisions you take. So this is called the machine learning. So machine learning is nothing but an artificial neural network with a linear perceptron having interactive features, data mining, and chatbot. And in interactiveness, you have graphs, maps, charts. Then features, you have models, timings, and deployment. Then in data mining, you have your algorithm, hyperparameters, classification regression, cluster analysis, time series, and anomaly detection. And finally, it comes out as voice or text based. So this machine learning is going to be going for a higher space, which is going to go with the intelligence, which is called as deep learning. So now you have to understand deep learning is also a form of machine learning, but a higher level. So it is an artificial neural network, but it has multiple layers of network. It is not a single network like a AIML. That is artificial intelligence and ML. ML means machine learning. Now it is going to be AIDL, artificial intelligence with a deep learning. Here you will have multiple layers of network. It will be of non-polynomial activation. Non-polynomial means you don't have any kind of a formula, like algebraic formula, x square plus 4n plus 3xy plus. No, it will not be in that form. It will take all other inputs. That is called non-polynomial. And then hidden layers of unbounded width. See what you think, what other people think, or for same action will have different reasoning. So each one will have an unbounded width of reasonings in them. So similarly, the machine is going to interact with a lot of people within your, if you own a machine and you keep it in your home, it is not only you are going to use it, the machine is going to be used by other people. So for each one's taste and their preferences, the machine has to get in. So it has to analyze a lot of unbounded width. So what is that unbounded width? The inputs for this is called bioinformatic inputs, like vision. What I see, what you see are entirely different, but we see the same thing. Similarly, smell. I smell, you smell, something will be good to me, something may not be good to you. And then speech. I speak out, sometimes you can understand, you cannot understand. Similarly, can be for me. And the sounds, something will be interesting to me, something may not be interesting to me, what I hear. And then touch. When I touch something, it can be happy with me, or it will be, I may not like it. And then the taste, similarly, what goes into me and how I cherish it will be different. So all these, and the inputs like vision, smell, speech, sound, taste, touch is going to be taken. This is called the inputs for deep learning. So this deep learning inputs is integral part of a non-polynomial activation with a hidden and unbounded width of preferences and practices, and it is going to be biosensory. What this machine is going to do is it will recognize, it will probabilistically analyze, and then translate it for an action. This is what is called the deep learning. So it is going to be connected to AI, and then the deep learning is going to happen. Okay. The next part is called the cognition amplification. See, human beings, we as a human being, we sometimes, within us, some people will be smart, some may not be so smart, some may not be to any end, but they will be good to themselves. Okay. So like this, if you see people itself, there will be a lot of varieties of people. So the machine should not get confused. So it has to be fed with data which is right. It should be fed with data which is wrong, and it should also be fed with data where it has to be innovative and creative. That's called novel. So you have to create a kind of when you create products which are going to be very creative and superior to equaling to a human being, then this transhumanistic has to be programmed. This is where the important part comes. A cognition amplification is the part which happens with big data. It has a processed algorithm and then goes with the cognition correction and amplification. I will tell you what is this meaning. If you have all these data, you process it and you get it, then there will be three outcomes from the machine. One is called adjustment. Anything you have to adjust for all the variations which has gone into the machine. So the machine will give out an output based on the adjustments. Then resilience. It will go through a lot of adversities. Sometimes temperature may be high. You will feed it with the wrong data. Everything it has to check. It has to go through. It has to verify. It has to hush. It has to accept and do with the resilience part, and finally give you a kind of recommendation also. Recommendation is like this is where the important part is. Human beings have deficiencies. Like no two people have the same amount of attention span. People may not have much attention span. People will have very big attention span. Somebody will be having more meticulous devotion towards being attentive. So no two people have the same kind of attention span. But when you use a machine, it should have an attention span which everybody can be relying upon. Then the memory. We will forget something, but the machine will not forget. And no two people have the same memory levels. And then the processing levels. You tell something to somebody, people may forget it quickly. So they will keep only in short term and they'll forget it. That's called the transient memory. But a memory which goes into the machine is called a long-term memory, which becomes permanent. Even if you ignore, the machine will say, this has happened this time, so should I carry on with the same aspect? So a deep learning that goes on. This is called a cognition amplification. So the machine now is becoming intelligent. But how is it intelligent? It depends on the sensors. The sensors which you use in the machine. See, the sensors are for vision. We normally use image CMOS. CMOS is nothing but a complementary metal oxide semiconductor. This CMOS can capture a black and white, which is called a monochrome picture or a color picture. So based on which, if you take a monochrome picture, then the the way of seeing it will be different. When you see a color picture, it will have its different way of understanding. And then the smell. You have a lot of sensors like volatile calorimeter, infraspectrometer, gas chromograph, or mass spectrometer. All these things are used for smell detection. Then speaker. It can be speaker dependent or speaker independent. Both sensors are available. Then sound, whatever you hear, that is, it depends on the acoustics. It can be with the pressure, it will go with the amplitude, everything of the waveform, sound form, which it can understand. Then the next part is touch. Touch is capacitive or resistive. Both the touches will be understood. And then the taste, which is called the chemical, microbial, pH, or titration. Okay, see, all these things sensors are now already into machines. I will tell you in what type of machines you have it as of now, as I'm about to complete the lecture. For now, I park it here, and then I go on to the next one called the smart tools. See, when people are intelligent, it means they stick on to time. Like they use organizers, they have calendars to go on with the dates, schedulers to work out their time requirements, reminders to be on time. You use many things, and then you show your smartness. Then you also show your smartness by using knowledge resources or search engines like Wiki or Google or university library resources, and then you pick your data based on which you show your smartness. Then the visualizations, you read charts, maps, graphs, dashboards, many things, and then you accommodate yourself accordingly. And then you also have the option of expert opinion. If you don't know, you can go for an astonishing breakthrough, contact people, get new pathways, surprising researches you can do, because two people will have more inputs than one single person. So you have this benefit. Similarly, you also have signs, symbols, sounds, signals, and gestures, which the machine should also be fed with. Now, it is already there, like oculogram, which when you have the oculogram tool, it can see your eye movement, it can see and find out how much of your perceptual process is going on, how much is your attention control is going on, and then accordingly the machine can keep reading. Then it can read your mind also. That's called encephalogram. Those aspects of these tools will read your mind activities. Then dermalgram, a dermal activity, your skin, whether it tells you live or when you're happy, how your body changes, your skin galvanism changes, everything is measured. And then myogram, how your facial expression comes. So if all these things are also put into machine, machines will become smart as equal to human beings, and then they will be in a position to give you deep learning inputs. This is where the deep learning is coming into play in machines. But okay, those are all for machine building. But for you people, how to get into areas where you can get employed in deep learning skills? Deep learning skills require the following. One, math skills, all the mathematical skills. Then the programming skills. What are the programming skills? If you learn, you can get a job in these kind of organizations. Then the learning algorithms, ML algorithms. What is that you have to get exposed to so that you can learn, get employed. And then the deep learning algorithms and frameworks that you have to get specialized. You need not get specialized in all of these. You can pick one area, specialize in that, and aim for your employment. Okay, as I go further, I'll tell you what are those. See, math skills, if you see, there is something what we studied like probability, statistics, linear algebra, calculus, etc. So in probability and statistics, you need to have concentration on Bayes theorem, probability distribution, sampling, and hypothesis testing. In these three areas, if you take and you become a master in this, you get an opportunity for getting employed. Then linear algebra, matrices and vectors. If you can get yourself, cherished on to become a specialist on that, then you can. Then calculus, all the differential calculus and the integral calculus. This also gives you an opportunity towards math skills employment. Then in programming skills for deep learning, there are 4 programming skills which are on take. One, Python, R programming, C programming, and Java. I heard in Northwest University, you have some of these already being exposed to the students. So to whatever you are exposed, become a specialist, put your time and effort and energy into it so that you can learn and come out with it. Next, for the deep learning skills, there is a software called Hadoop. If you can get an opportunity to get specialist on this Hadoop framework, which is working on all the SQL framework storages, the data databases, and then clusters of hardware, then you also have an opportunity to become a systems integration specialist into deep learning. This area is again a very good opportunity for people who are trying to get their employment into it. Then coming on to the data skills. See, big data, I said, big data, you cannot get everyone get into big data. But for deep learning data, you can do the deep learning data pre-processing activities like cleaning a data, parsing a data, collecting a data, consolidating a data. If you can get experience in these areas, that is also good. Then the ETL part, the extraction, transformation, and loading of data, then you can also have an opportunity to get employed in DL, organizations. And then on the database, you can have exposure to MySQL or Oracle DB or NoSQL. NoSQL is also called as a DynamoDB or MongoDB. If you get Hadoop and MongoDB is the best kind of an opportunity for getting employed. See, people with Hadoop and MongoDB experience, they get about a minimum of 75,000 US dollars as annual package at an entry level. So it's something around 6,500 US dollars plus at an entry stage. So that is the high, kind of a lure you can have for yourself if you want to increase your earnability. Then coming on to the deep learning aspects. Deep learning skills go on with ML algorithms like naive-Bayes, decision tree, support vector machine, random forest, k-near neighbor, k-means clustering, or linear regression, hierarchical clustering, logistic regression, or a priori. All these are all algorithms, ML algorithms, which are used in deep learning. So you can identify which area you want to get, learned upon. See, when you want to get into these algorithms, it goes with your programming. When you want to get into algorithm, you should know programming skills like either Python or R or C++ or those basket on which the deep learning is being built. Okay. Then the next is the framework. This is conceptual. This is conceptual. You have functional people. It doesn't go with only technical, IT guys. It goes with artificial neural, like any biology or physics or chemistry oriented people and maths oriented people. They can also study artificial neural, generative adversarial, convolutional neural, deep belief, recurrent neural, long-term short-term memory. All these, like how human beings are requiring it so that the machine can be tuned and it can accept and it can use it in the future. So I've given you the kind of a technical inputs or the opportunities that is lying ahead. Now I'll show you who is going to employ you. See, before I go with the employability things, there's a framework in the sense, see, for example, you learn something, it has to be put in a certain form of a way. There are frameworks like TensorFlow, Keras, Theano, DL4J, Scikit-learn, Caffe, MyTorch, Microsoft Cognitive Toolkit. All these are the frameworks also available. But I doubt whether this is available in Africa. But you will get it online from any of the Western countries or from India also. These learning frameworks are available as a online learning. Okay, then the final part, employment. So who is going to employ and what they should have been mastered with? A master's degree with ML is essential because it is going to be used in DeepL. And those people who come out with ML should have an undergraduation either in computer science, statistics, electrical, maths, or science. Okay, don't worry if you are not within that. For others with experience in the field, you can get it. It means you have to learn the tools, technologies, and the software, and then prepare yourself so that you are competent enough for being eligible for this selection. then experience. If you are having computer programming like Java, Python, C++, then this is also a better opportunity for you to get employed with. Okay. The organizations that are going to employ you, or the companies, are these are very branded ones. But this list is not the final. There are many other companies that are just taken because of their brands. Microsoft, Google, Intel, Nvidia, Apple, FE, Facebook, Amazon, IBM, Sensory, Qualcomm, all these companies are giving a lofty salary and better career opportunities. Okay, now I stop. I want to know from you what you have understood and where you want to get clarified. So accordingly, you can go ahead.
Okay, thank you.
I leave it to you, Joshua.
Thank you so much. Thank you, Doc, for this detailed presentation, and which was able to show us different dimension of deep learning and machine learning. Because, like I said from the beginning, that is where the world is, and that is where the world is going for the future, and it's good for any person, for anyone that wants to go into that field of profession or career. So now I think I leave it open for everyone to throw in their questions so that we can discuss. Thank you so much. So the floor is open for anyone who have idea, question to ask. Please feel free right now to bring in your questions. Thank you.
I'm available. Don't feel shy. Don't feel left off, because if you leave this opportunity, you can ask me again. Huh? So
Yes.
ask me whatever you want.
Okay. Student, please feel free to ask your question. Remember, this is a very new area that is growing right now, and please feel free to ask your question. Okay, let's hear from Martin.
Hello.
Yes, Martin.
Yeah, Martin.
I need to ask about this search engine algorithms. I need to understand how they really work, because I was online the other day, and then I entered a certain website, and then after that, when I go to Facebook, I see an advert of that website. So I saw their advert. So I thought that it's some kind of censoring and stuff like that. So I need to understand how this kind of algorithm works, because I need to know more about them.
Okay, I'll tell you. Like, see, this search engine algorithms are dependent on keywords. So if you type a keyword, and that keyword when it matches with the database, then it will pick that data and it will show you as a link. There are a string also. It need not be keywords. It can be a question like, what if I have to join an organization with DeepL, and then the string divides itself as what plus if plus organizations plus DeepL. Accordingly, it will create a kind of a formula, equation. So every word will again be again searched with the database, and then the links will be aligned. So where if you have a keyword, then it will pick all the contents which is in the database. If you put a string, it will get the maximized kind of a results which are matching your thing. Then it will push it out. So similarly, see, for creating a kind of an algorithm, you can do even from any kind of software packages with DOS based, or you can have any kind of a thing. It doesn't matter with what kind of SQL you need to have. Okay, you need not go even for no SQL. Okay, but the way how you construct the way of capturing is called the search engine algorithm. Okay, So this comes out of experience. You can find out a lot of people who are offering search engine algorithm training. So learn from them and you can do it.
Okay, thank you so much. Thank you so much. Kutuano?
So I would just like to ask, is machine learning and deep learning different things, or does deep learning fall under machine learning?
Thank you.
Okay, very nice question. See, machine learning is the base over which sits the deep learning. So machine learning is a polynomial algorithm. Deep learning is a non-polynomial algorithm. Machine learning is a linear perceptron, whereas deep learning has a multiple layer of networks. This one has a base width, there it has hidden width. So whatever you can, put it as a formula is a minimal work which a machine can do. But bio information that can go is called a deep learning.
Okay.
Hope you understood.
No, please, could you please just repeat that last part? The last part you just said.
See, deep learning is not dependent on formulas, doesn't depend on algebra, does not depend on your mensuration, your calculations. It goes on with what you see, what you smell, what you hear, what you touch, what you taste. All these are biosensory informations or inputs. This is what on which the deep learning works. Whereas machine learning works on normal formulations, like your algebraic calculations, your polynomial calculations, your integral calculations. Everything goes on with the your normal ML. Deep ML is a higher one.
Okay, thank you.